Welcome to part 2 of this AR clock tutorial. If you just joined, here's what we're gonna make. In the last part, we already set up the scene, so in this part, we're going to do all the coding. So let's get started. Let's just go down here, and we'll just do the code. So I'm just going to do a bit of cleaning up. Also for scene, we renamed the scene, so we also have to change it here. Since we're grabbing the scene from we're grabbing the scene file and using it. But anyways, I'm going to also get rid of scene view.show statistics because I don't want to show any stats about frame rate and stuff, because I mean, it's good for debugging, but if you want to present it, it's not the best. But yeah. And I'm also going to delete these functions here as I don't believe we will need these. Alright, so now we've got that down. I'm also going to add a few variables. So first I'm going to add a container, which is an SEN node, but I'm gonna make them optional because at the start we already set it. So I'm just gonna make an exclamation mark saying, hey, this definitely exists. I mean, even though we haven't set the variable to anything, we know that from the start we'll have something. So I'm going to set the container in the viewed alone part, which is a start, like when you start the app, or when you floated all the view or all the stuff and everything's set to go. So I'm just going to do scene.root node, and that's going to equal scene.root node with name. So the name of the container was, well, it should be container, yeah. Container all lowercase. So you have to make sure that it's completely the same. Like, I mean, you just have to make sure everything is the same. So I'm going to do container. And also recursively, I'm just going to set that to false. Because with recursively, if you set it to false, it only checks for like the first layer. If it's true, then it'll check all the children of its children, and then work down. But it's more efficient to set to false, even if it only makes a tiny difference. It still makes, it's still quite important if you're making very, very complicated games that uses a lot of your device's memory or processing power. Anyways, let's not get too deep into it. Let's not dive too deep into it. And also, what I'm going to do is I'm going to do container dot remove from parent node. The reason why I'm doing this is so the container gets removed, and so we can put it, or because we're going to anchor it to the image, and that means that we have to put that container inside this node, which is attached to the image, or the anchor for this image. And I mean, it's not really necessary, but it's just good, just so you don't, let's say, have multiple duplicates or anything like that. Also, I'm going to create another variable, which is the time text, which is going to be our text for telling the time. And so what I'm going to do now is I'm just going to do time text. Time text equals to container dot child node, and that's going to be let's check the name. So it's time text. There we go. So time text. There we go. And recursively false, because I don't want to search the whole container, I only want to search for like the first, I guess, layer inside the container. And just like I did with the container before, I'm adding I'm gonna add an exclamation mark, which is for force unwrapping the text, I guess. Yeah, force unwrapping the text, because when you search for the child, maybe you got something incorrect, or maybe that node doesn't exist, so it'll just return nil. And I'm just doing that just to confirm that, there is something. Anyways, next I'm gonna go to geometry. Actually, what I can do is I can do this, geometry. And I also have to unwrap this, because sometimes it's an empty node without geometry. Or actually, what I could do is I could add a question mark, just saying that, oh, maybe there is something, maybe there isn't something. Because what I'm going to do is I'm going to do .geometry as a SCN text. Because I've set this to be an SCN text, and which is like a text geometry. So if I'm doing as SCN text, then yeah, that's I can put an exclamation mark saying that it's definitely as an SCN text, and we can definitely unwrap everything that's before it. And it says treating a force downcast to SCN text. Okay, so yeah, never mind. I'm just gonna leave it like this. And so what we're going to do next is we're going to add some stuff for when we detect the image. So next I'm just going to do renderer. Yeah, there we go. Renderer did add node. And this is basically just tells us, oh, maybe we've added this node because we've detected an image, but it's not necessarily a node. It could be like a plane, it could be really anything. So I'm gonna have to check if the anchor is an AR image anchor. If not, then I'm just gonna return, and that means that you just get out of that function. Just say, hey, we don't want to go through with this. This is not an AR image anchor, so we're just gonna ignore this. Just say, never mind, I don't care. But yeah, that's really what it is. And I'm gonna add the container to a node, and that node is always attached to the image that we're going to find, or that we've already found. No, I want to do node add child node, and that's going to be an the container. There we go. Oh yeah, and I almost forgot one very important thing. I'm gonna have to change this AR world tracking configuration to AR image tracking configuration, because we're actually just, yeah, because we're tracking images, not finding planes. Anyways, so I'm going to have to also get the images that we're going to track in this AR resources folder that we made back in the start. And so I'm going to do a guard let so we can grab it, because sometimes it may not exist, but we're forcing it. So if it doesn't exist, then we're not going to continue this. We're going to stop it. But of course, it's going to exist. It's not like it's going to suddenly delete itself. Anyway, so I'm going to create a constant called tracking images, and that's going to be AR reference image dot reference images. There we go. And the name of that of the group that we made with the image that we want to make, or with the image that we put in that's yeah, that's in the assets, the XE asset. So it should be called AR resources. So yeah, basically that is just this folder here with the image inside it. And so let's go back to view controller, and I'm going to select, or I'm going to put in AR resources, and you have to make sure that all the capitalization is correct. And bundle, I'm just going to set it to nil. And if we can't find anything, just like before, I'm going to set it to return, or I'm just going to return. I'm just going to return, like, get out of the function. And also, we also have to do configuration dot tracking images equals to tracking images. There we go. So back down here, I'm going to have to unhide the container. So container dot is hidden equals to false, because before it was hidden and then now it isn't. And it seems like I just got a notification on my Apple Watch. Anyways, let's keep going. So I think we should be able to run this and make sure it's all good. So I'm just going to up here, I'm gonna select the iPad that's attached, and I'm just going to run it. So yeah, and Command R. There we go. So we're in the app, and I'm going to open up the Photos app on my Apple Watch, because we have this stuck here that we're going to detect. So I'm just gonna. Ooh, there we go. Oops. So we can see that we have some. Well, the text is quite big, but oops. So if I aim this over here, yeah, you can see that we have this here, and the particles are here, and everything's good except for duck. And I think I know the solution to that problem, so I'm just going to go ahead and fix it right now. Anyways, so let's just fix those problems first. All right, so we're back, and well, let's fix those problems. So first, the duck, and I hoped that this problem wouldn't occur. I thought that this wasn't too much of a problem, but it seems like the problem is that with the duck, it's not scaled properly, or not scaled. I'm saying that because this is a reference and we just dragged it in. I guess I'm not sure if it's a bug or if I'm doing something wrong, but it's not. It doesn't seem to be loading properly. I believe it's more of a bug, but anyways, let's just go ahead and drag in an empty node. I'm gonna call this duck, and this is just gonna be some container for that we're gonna drag this in. So what I'm gonna do is I'm gonna copy this by doing Command C, and then if we go into a C, I'm just gonna do a Command V, and then I'm just gonna copy in all the stuff. So like 0.046. So just like the scale and all the rotations, and so I'm just going to drag it. I'm just gonna drag it just so it kind of matches what the previous duck was. And then after that, I can just delete this, the original duck, and also I can delete this DAE file because I just made a copy, and we shouldn't need it anymore. All right, so here we go. We have a duck, and okay. So the next problem is it's really big. So I'm gonna scale it down by, let's say, down to 0. maybe 0.3, just so it's a little smaller. It's just like smaller. And I'm gonna run it and make sure everything is all right. So let's hide this again and do a command and press Command R. And there we go. The scaling is a lot better. And yeah, this is amazing. Great. So we can go ahead and make the time work, and after that we should be done. So great. All right. So actually, yeah, there's something else that we forgot to add, and that's oh, remember that box? Yeah. So I'm gonna make the particles bounce off that box. So I'm gonna create I'm just gonna do a let constant called particles, and that's gonna be container dot child node with name. And remember, it's called particle, or I think it's particle. Oh no, it's particles. Okay, particles, and recursively false, because we don't have to keep searching. I don't want to keep searching like through the whole container. Anyways, after that we have to set it so it bounces off that box that we just made, and I believe that box is just called box. Yeah, it's just called box. That's really easy. So what we're gonna do is we're just gonna do particles dot particle systems dot first, because we only really have one, and we're gonna do dot collider nodes. In fact, collider nodes is just a variable which we can set, and it just tells the computer or the device, oh, what should particles collide with, and you can do many, but we're just gonna choose one, and that's the box. So I'm gonna set it to container.child node with name. I'm gonna set it to box and recursively false, and I'm gonna force unwrap that. So now the particle is colliding with the box. And I think that's all we need to do for particles. But after that is the time. So what I'm going to do is I'm going to do an update function, and I mean, maybe there might be a better way of doing this, but I'm going to set the time, or I'm going to get the time and set it to this time text, right? So the reason why I'm doing it, why I'm updating it every single frame, is mainly because if you think about it, we're doing hours, minutes, and seconds. Now, if we were doing only hours and minutes, we could probably do it maybe every second, and it shouldn't be that bad. But hours, minutes, and seconds, basically, we want it to be quite precise, so it changes, the second changes every, we can update the second every frame, just so, because there might be some delay or lag. But anyways, that's some complicated time stuff. Anyways, so first I'm gonna get the calendar, which is, well, it's mainly a calendar, really. Actually, calendar.current. So basically, it's what we're going to do. So we're going to get the time by doing let time equals to time. So it's just time. Actually, it's not time, it's date. Well, I got that wrong. So yeah, the date is date, really. And so what I'm going to do is I'm going to let time equals to calendar dot, and it's date components from date. So basically, yeah, you're getting the hours, minutes. So I want to get the hours, minutes, and seconds from the date. And so what we can do is we can just do create an array in the first parameter, and just do .hour, .minute, .second. Really, you can even go down to nanoseconds, or you could even do like the day, the month, the year. Really, I mean, you can choose from any of these. You can do weekday, anything really, era even, era. Anyways, I'm just gonna just do hour, minute, second. So, and we're gonna get that from the date. Okay, so the next thing is we need to get all that. But also, I want to make it so for the if it's a single digit, I want to add a 0 before it. So, but if it's 2 digits, I don't want to add a 0 before it. So, basically, I just want to make it, I guess, the length of the text the same, and also that's what happens with some of the digital clocks. And so I'm going to do create a few variables. So 0. So I'm going to do 0 before hour, and then I'm just gonna. And then what I'm going to do is I'm going to do this condition, or more like a mini if statement. So I'm going to check time dot hour, and also I need to unwrap that in case it's an optional, because I don't know, something might happen with the time. Maybe you can't get the time or anything. Maybe time doesn't exist. Anyways, time dot hour. So I'm gonna check time dot hour is less than 10, and if it's true, I'm just gonna set it to 0, and if not, I'm using a colon for if it else. I'm gonna set it to nothing. So if it's less than 10, I'm just gonna do a 0. So it's like it's like something that we're gonna add on. Anyways, we're gonna do the same thing with with minutes and seconds. So I'm just gonna copy and paste it. So 0 before minute, and then 0 before second. So, I mean, this is how we get the time, really. That's really it. That's really all we need to do. And then after that, we're just going to do text, the time text, dot text, time text dot string. Very good. I'm pretty sure it's string. I can check. We can check when we run, but it should be. So I'm gonna do after this. I'm gonna set to 0 before hour, and then time dot hour, and then remember to unwrap it. Now, so this is the structure that we're going to do. So 0 before hour, time dot hour. 0 before minute, time dot minute. And remember that maybe sometimes it's an empty string, so that doesn't really affect anything. So I mean, this is my way of doing things. It may not be the correct, or it may not be the best answer, but it's, as long as it works, it should be all right. Anyway, so after this, we're gonna do 0 before minute, and then time dot minute, and also remember the colon. And then after this, we're gonna do 0 before second, and then we're going to do time dot second. And yeah, I'm separating it with colons. You could separate it with whatever you want. Dots, I mean, depends on where you live, I guess. And okay, so that's all good. And yeah, so we have the time. We have the time down. Yeah. And also, uh, bear in mind that this is a 24-hour. This is going to be a 24-hour clock. All right. So without further ado, let's just do Command R, and yeah, we can just run it and make sure it works. All right. So the app's open, and I'm really excited because if this is done, then I'm all good. So remember the photo on the Apple Watch. And by the way, you don't need to use Apple Watches. You can use name cards or like, I don't know, paper or whatever you want really. So I'm just doing Apple Watches because it just suits. And as you can see that some of the particles are bouncing off, and the time is all good. So there we go. It's all good. And there's a bit of reflection. So sometimes it's not the most. Sometimes it might wobble, but because this is an Apple Watch and it's made of glass, and glass is reflective. But anyways, this is really good. Yeah, I mean, amazing. We have a AR clock on our arms, by the way. I mean, it's an Apple Watch and it also tells the time, but I think AR clocks are a bit more impressive. Anyways, I think we're done. So, all right. So we've got an AR clock. It looks great, and I mean, this has been amazing. So thanks for watching, and well, let's go to the intro. Thank you for watching my video, and I hope you've enjoyed it.